Hey y'all. Okay, so this week's homework is about doing the calculations for acids and bases. And on each page of the homework, I put this graphic. I really like this graphic because it's everything in one place. And I'm just going to do one example off each page so that you can see how to plug these things into the calculator. I feel like the graphic is self-explanatory, but you might not know how to do log and inverse log functions on your calculator. I think you need a scientific calculator with a log function to do this. Some cell phones have this, I think. So if you don't have this, if you're at home, you can find a scientific calculator on Google. If you just go to Google and put in scientific calculator, it'll pop its own calculator up on your screen, and then you can use it that way. So anyway, all right, so let's just get started. On question number 1, there are 3 questions, and I'm going to do the first one for you. Okay. So it wants you to calculate the pH if I give you the concentration of hydrogen ions. So the brackets mean concentration. Okay, so if the concentration of hydrogen ions is 1.2 times 10 to the negative 2 molarity, what is the pH? So if you find that on your bracket, on your graphic, you're going from concentration of H to pH, so you would follow this arrow here. So this is the formula you would use. The most important thing is to really watch where you put those negatives. When you're doing log, you have to put negative log and then put in your concentration. Okay, so I'll show you how to do that. So don't hit minus, hit the negative sign. Oh, this isn't on. Hold on. Okay, are we on now? Okay. So yeah, don't hit minus, hit the negative sign, and then hit log. So it'll look like that, and it opens a parentheses for you. So in that parentheses, you're going to put your concentration of H, and you're going to put it in the way we've been doing it all year. Don't hit times and don't hit 10. You're going to hit that second exponent. So it's going to be 1.2 second exponent. And then again, don't hit the minus sign, hit the negative sign that's down here. Negative 2. So it should look like that. And then you're going to close those parentheses. And then you could hit enter. And that's your pH, 1.9. Okay. And a really kind of quick, dirty way to check your work is your pH will be about the same as this negative exponent. It's not always going to be the same, but it should be sort of close to it. That's one way to just sort of check your work really quickly. Okay, so you'll do the other 2 questions just like that. Okay, let's do an example of going the other way. I'm going to timestamp this in case people want to jump around a little. Okay, so if I give you the pH and I want you to find the concentration of hydrogen ions, you look at your graphic. So you'll be going from pH to your unknown. You'll be following this arrow. So this is your formula. And again, that sneaky negative sign is the most important thing. If you forget that, it really kind of screws up your whole thing. So this is 10 to the power of the negative pH, or what we would call the inverse log. And so if you look on your calculator, on my calculator, here's the log button, but let me see if I can raise that up. See how if I hit second, it takes me to above the log button, and looky there. So above the log button is the inverse log, and it's 10 to x, x meaning that's the part you put in, all right? So when I want to do, if I want to do the inverse log, I'm just going to hit second log, and see what it opens here? Can y'all see that? It gives me 10, and the caret means to the power of, right? And it says, okay, cool, give me your exponent. So my exponent is the pH, but with the negative sign. So don't forget the negative. That's the easiest part to forget. So not minus, but negative 2.5. And then close your parentheses. And then when I hit enter, I should get that, right? Let me show you real quick how to write this in scientific notation. Okay, so let me say concentration of hydrogen ions is, you write it the way it's on my calculator, 0.00316. Let's just stop there. If I change this to scientific notation, let me zoom in a little. Ooh, zoom in a little. There we go. If I change this to scientific notation, I'm going to move my decimal over until I have one digit to the left of the decimal. So it's going to be 3.16 times 10 to which power? And then count how many, and that's a negative when you go this way. It's a negative. Okay, so -3. Okay, so that's how you would convert that to scientific notation. So I'm showing you that because if your answer isn't like a crazy big number, then it's going to show up like that on your calculator. But I would really like y'all to know how to convert that to scientific notation if you have to. Okay, let me zoom out. Oh, that's the wrong way. Is that it? Okay. So the other two questions on number 2 are just like that one. Okay. So 652, we're going to jump down. I'm just time stamping this so people can jump around. Let's look at question 3. This is really easy. Okay. If I give you either the POH or the pH and want you to find the other, this is really easy. You just do 14 minus your given. Okay, so sliding back and forth between pH and POH is super simple. It's just going to be 14 minus whichever one I give you. Okay, so I'm just going to do the first one for you. Okay, so if I give you a POH of 5.18 and I want you to find the pH, I'm just going to do this. I'm going to say 14 minus, what did I say, 5.18? 5.18 is 8.82. Okay, so the other 3 questions on this section are just like that. Okay, turn it over to question number 4. Well, you're not turning, I'm turning. Okay, so question number 4. And this is at 8:05. All right. What is the hydrogen concentration if the hydroxide concentration is 5.42 times 10 to the negative 5 molar? All right, so let's look on our graphic. I am given my hydroxide concentration, and I want to find my hydrogen concentration. So it doesn't matter which way I'm going. Those two things multiplied together will give me 1 times 10 to the negative 14. So, which means when these are my given and my unknown, to find my answer, it's just going to be 1 times 10 to the negative 14 divided by my given. Okay, so this type of question is solved this way. Okay, so let's do this one. What is the hydrogen concentration if the hydroxide concentration is 5.42 times 10 to the negative 5 molar? Sorry, y'all can't see that. So I'm just going to let me put this where y'all can see it. Let me zoom. Can I zoom out anymore? Oh, I can. Okay, there we go. Let me put this right here where you can see it, and you can see the question, and you can see my calculator. So I'm going to just start with this number. 1, don't say times 10, say, oh, that's 11. Oopsie. 1 second exponent, negative 14, not minus 14, but negative. Make sure you're using the right button, right? Divided by my given, 5.42. Did I do that right? Yeah, 4 to second exponent negative 5. That's my answer. So my hydrogen concentration is 1.8 times 10. Don't forget that negative to the negative 10. Okay? All right. So a little bit of a trick question because your next question is going to be just like that one that I just did. But look at the next one. It's a two-step question, okay? It's going to give you the hydroxide concentration and it wants you to find the pH, which means you'll be going corner to corner. If this is your given and this is your unknown, it doesn't matter how you get there, but you're going to have to do a two-step conversion, right? You can go whichever way you want. Either first find the hydrogen concentration and then convert that to pH, or go the other way. You might have to find the pOH and then subtract that to 14. When I have to do these, I think this is the easiest calculation on the whole graphic. So when I have to choose a route, I always go through this top one just because I think it's a lot easier than dealing with log. So anyway, that's just how I would do it. You do that one however you want. And then I think I ended up not putting this on there because it was going to be way too easy an answer for you. Okay, so that's it. That was short. Yeah, okay, I'm going to stop this now. So please log on to Zoom if you have any questions about that. All right, bye.